So in part one of this screencast, we looked at the various threats to biodiversity, and we used the acronym HIPPO to keep track of all of them. Habitat destruction, invasive species, population growth by humans, pollution, which we're in the middle of discussing right now, and then over-harvesting. So I want to continue talking about pollution and specifically looking at altering the atmosphere through pollution. So maybe you've heard of CFCs before. Maybe you haven't. I'm not even sure. But in the 1980s, CFCs were these terrifying chemicals because they destroyed the ozone layer. And these were chemicals that were found in insulation materials, little spray aerosol cans that, like hairspray and stuff, refrigerants and air conditioning refrigerator, that kind of stuff. Um, so I want to talk about CFCs and what they did. So before we get into that, though, we need to understand the ozone layer and what it does. So the ozone layer is a part of the atmosphere that protects us from harmful UV light. So you can see that, there's gases up in the atmosphere, and it's not like there's just this like band where this is the ozone gas is there and nothing else is there. But there's definitely a layer where there's a pretty high concentration of ozone. And you can see that UVB does not get through that ozone layer very well. And UVB is kind of a dangerous wavelength of light. It can interact with cells and cause skin cancer. It can cause cataracts, which are these cloudiness in your eyes due to damage to the lens. It can cause damage to crops. UV light can cause a lot of problems, and so the ozone layer protects us from that. And the way it protects us is through a natural cycle. There's a natural cycle where ozone is destroyed but then reformed. And this picture kind of shows this. So ozone is actually O3 chemically, and here you have a molecule of ozone that is struck by a wavelength of UVB radiation, and it's destroyed. And then there's a series of chemical reactions that happen, but ultimately we reform the ozone. And there's this natural cycle. UVB destroys it, and then it reforms. Well, unfortunately, these CFC chemicals produced by humans and released into the atmosphere as pollution disrupt that natural cycle because they release chlorine atoms into the environment, which then interact with ozone and destroy the ozone without the aid of UV light. In other words, it creates ozone destroying chemicals in the atmosphere. And even worse, these chlorine atoms are catalysts. And you may remember that enzymes are catalysts, which means they help a reaction happen, but they aren't used up in the process, which means that some of the CFC molecules released in the 1980s are likely still up in the atmosphere and still destroying ozone molecule after ozone molecule after ozone molecule. So that's bad. And this was discovered because there was a hole, is what they called it, but this little gap in ozone concentration. And in red on this picture, you can see high concentrations of ozone. In blue, lower concentrations. And you can see in the 1970s, we had pretty high ozone concentrations. In the year 2000, pretty low. And again, this was first identified in I believe, the 80s. Well, this was a problem. And so the solution was simple. If CFCs are destroying the ozone layer and we are dependent on the ozone layer for our health and livelihood, let's stop producing CFCs. And so various governments got together in Montreal, Canada, and they enacted what is called the Montreal Protocol, which is an agreement that said we are going to slowly phase out the production and use of CFCs. And you can see on this graph that after the Montreal Protocol in 1987, CFC's use declined, and the ozone layer is actually shrinking or reforming. It's the hole is shrinking, and the layer is strengthening itself. And whew, crisis averted. Good news. We saw the thing causing the problem, and then we stopped doing the thing causing the problem, and then the problem goes away. Beautiful, right? Unfortunately, there's another issue that we're still kind of working on along those lines, and that is climate change. And so let's talk a little bit about climate change. First of all, what is it? It's basically a change in weather patterns over an extended period of time. You may have heard of this as global warming. that term has been abandoned because, first of all, not all areas of the world warm up, and the changes are way more diverse, as we'll see, than just changes in temperature. So climate change is kind of the accepted terminology now. Um, and it involves these things called greenhouse gases. So let's take a look at this natural cycle. Here's the natural cycle that's supposed to be happening. We call the natural cycle the greenhouse effect. And basically, we have what are called greenhouse gases in the atmosphere. Examples include water vapor, carbon dioxide, methane, and yes, even ozone. These are natural things in the atmosphere that are supposed to be there. And what happens is the sun shines down upon the earth and it sends all sorts of wavelengths of light, and that warms the earth up. And you know this to be true because if you touch a sidewalk in the summertime, it's hot because it has been warmed up by the sun's radiation. Well, some of the wavelengths bounce off the earth and kind of head back up. And some of the wavelengths are able to pass through those greenhouse gases and escape into outer space. But some of the wavelengths of light, notably infrared light, is actually absorbed and re-emitted by those greenhouse gases. And that essentially traps those infrared wavelengths. Now, infrared wavelengths turns out is basically heat. So essentially, these greenhouse gases are trapping heat in the atmosphere and keeping our planet warm. And it turns out this is a really important thing, and we would not be on this planet living like we are without it. It keeps the temperature good for life. So the greenhouse effect, thumbs up, good thing. Unfortunately, though, humans are disrupting this natural cycle by increasing the concentration of greenhouse gases in the atmosphere. Two big examples, carbon dioxide emissions, sometimes just referred to as carbon, from the burning of fossil fuels, and then methane, CH4, which is released by cow flatulence, which is kind of funny. And that is largely because we eat a lot of meat. And so we have a lot more cows around, and yeah, anyway. Um, so because of this, CO2 levels have been climbing, and you can kind of see on this graph, carbon dioxide levels have been climbing. I just covered up the x-axis there, but it was pretty level for a lot of years, and then in recent decades has just shot way up. And so, you might hear people say, oh, it's only 350 parts per million. That's a very tiny amount. But if you look at the percent change from what it should be, it's like a 30% jump. That's pretty darn significant over the last couple hundred years. And then people wonder, well, where do you get these numbers from? In recent decades, it was a direct measurement from just from the atmosphere. And then in the past, they use ice core samples. They can drill into the ice in Antarctica and then figure it out from there. Um, here's just a picture. If we're looking at who do we blame for this added carbon dioxide, here's a lovely picture. And the United States is in yellow, and you can see historically in the 1970s, we actually were producing more than every other country in the world, just about. Eventually, we were overtaken by every other country in the world together. And then China has really taken off since about 2003, 4, and is now the #1 producer. But historically, we've been #1. Now we're #2. But we are contributing a lot of greenhouse gases, and then this kind of just shows the different places where those greenhouse gases are produced. Other interesting side note, you'll notice there's a little oscillation in CO2 levels every year. CO2 levels climb and then they go down, climb and they go down. And that's actually a seasonal thing. The CO2 levels go down every spring because photosynthesis. Leaves form on trees and pull in more carbon dioxide. And then when those leaves are dropped, then less photosynthesis happens and then the CO2 levels rise. So just kind of highlighting the impact of just trees on this makes a difference. So humans have added this extra carbon dioxide to the atmosphere and other greenhouse gases. And so the result of this is if we add more carbon dioxide, then there's more greenhouse gases to absorb the heat, which means we're absorbing more heat. And so what are the effects of this? Well, the main effect that's often talked about is rising average global temperatures. You would do yourself a great disservice if you skipped out on these top two videos. Both of these kind of show the temperature changes that have happened in recent decades, and they show it in quite a dramatic, staggering way. There is no doubt that the temperature is climbing. significantly in recent decades, and you definitely want to click on those and watch. Um, Here, if you're too lazy, here's just kind of a graph that kind of shows, this one on the right here it does it for Minnesota, but on the right it kind of shows the United States. Blue means that there has been really no temperature change from the average of 1901 to 1960 to the average of 1991 to 2012. And then the more red it is, the greater the increase in temperature has been between those two time spans. And so you can see most of the United States has gone up quite significantly, including Minnesota, in terms of average temperature. Um, Here's another graph of just average global temperatures. And the powerful thing here is these are independent records from different sources, and they all match quite dramatically. The average temperature is definitely going up. We're also seeing changes in precipitation patterns. We see drought in some areas. So out west, where it's a little drier, we see a lot of dryness. There's actually less precipitation there. And then in wetter areas, we're seeing more. And you can see Minnesota is definitely one of the more the darker color ones, which means we are getting more precipitation. So here's how much rain we're getting 1891 to 1920. And you can see blue is greater than 30 inches. And you can see that over the course of these various time spans, the amount of rain has definitely climbed quite dramatically in Minnesota. And you may remember the Duluth floods, 2012, huge flooding in Duluth, destroyed roads, homes. That was a big mess. And again, that's not normal. That's not something that's supposed to be happening. Another effect is increased wildfires. So, out west, I mentioned, is getting drier. And as a result, we are seeing more wildfires. Not only do we see more wildfires indicated by this number, but the average length of the wildfire season is getting longer. It used to be that about 5 months of the year, firefighters had to worry about this. Now it's 7 months. Um, We're also seeing a melting of glaciers. So here's just kind of some before and after pics that show some glaciers that have been melting. And there's different effects of glaciers melting. One possible effect, if the ice is floating like an iceberg, kind of like an ice cube in a glass of water, it doesn't really affect sea levels in any way because the iceberg is displacing a certain amount of water, and when it melts, it's the same amount, so it doesn't really matter. But if the ice is on a continent, like Antarctica or Greenland, if that ice melts, then that ice spills off of the continent, off the land, into the ocean, and sea level rises. And here's a graph that kind of shows what happens as sea levels rise. So you can see this line represents what's already happened, and Venice is already in trouble. Venice, Italy actually has some sort of setup where they're trying to keep the water out of their city because their city is it's already sea levels above their city. And you can see if sea levels continue to rise, LA, Amsterdam, Hamburg, San Francisco, Manhattan, depending on the amount, it gets worse and worse and worse. About 6 meters, this is where if all of the Greenland ice sheet melts, and then here is where like the Antarctic ice sheet melts, and you can see that's pretty catastrophic. So this is not something that's going to happen in our lifetimes. In fact, it'll take many centuries to get there. But you'll notice that that Greenland ice sheet thing, um, it's already melting at a rate of about 50 cubic miles per year. And if the average temperature goes up 2 to 3 degrees more, that's going to make this melting inevitable. Some people actually think it's already inevitable that the Greenland ice sheet is going to melt. So, this figure makes it seem like, oh my gosh, all these cities underwater, but it could be inevitable um, very soon. The melting and flooding won't happen, but the inevitability of that ultimately happening in centuries is inevitable. And then here's just kind of a little graphic that kind of shows Florida and New Orleans and what happens. Um, Another effect, increased frequency and intensity of storms. We're definitely seeing this. The number of Category 4 and 5 hurricanes has doubled in the last 30 years. And then altered distribution of species. This is a very sad video, and I would encourage you to watch it, that just talks about how climate change is affecting different species. Polar bears hunt on ice, and if there's no ice, they can't hunt, and it's pretty tragic. So I'm going to pause there, and then we'll talk about the solution to climate change on part 3.